Okay, here's another friction problem. Let's say that we have a road and a truck. This problem is in your book, by the way. It's one of the assigned problems, or it's related to one of the assigned problems. So here's how you do this. There we go. So it's a truck. It's a flatbed truck, and there's a box sitting on back of it. Okay. And so there's friction between the box and the back of the truck that keeps the box from slipping when the car accelerates. So let's say that you want this car to accelerate, let's say at 2 meters per second squared. And you want it so that this box, of course, doesn't slip. No slipping. So whether it slips or not depends on a couple of factors, including the coefficient of friction between the box and the bed of the truck here, mu. So the question is, what is the minimum value of that coefficient? Minimum value of mu for no slipping. All right. Let me show you what I mean here. So let's go to a simulation. All right. So I'm not going to make a truck, but I'm going to make something like a truck. So I'm going to make the ground here frictionless. All right, now here is your truck. All right, never mind that it doesn't have wheels. It's a rocket-powered truck, so let me put a rocket on this thing. All right, so there's 10 newtons of force. So now this is going to accelerate. Right. So now we're going to put a box on top of it. Bloop. And now let's do this here. And the question is that box also going to accelerate along with the bottom box here, which is the truck? Yeah, it does. But what if we change the coefficient of friction between these two guys? So for example, if I make the surface between these two slipperier by changing that coefficient of friction, there's still friction, but maybe not enough to get the blue box to accelerate. Oh, there's enough there. Let's try lowering it some more. 0.13. Oh, you know what though? Look, watch it. Let's make this accelerate a little bit faster. So let's increase the acceleration here. 50. Now watch what happens. Yikes, bloink, it fell off. So there's still friction, just not enough friction. So look, now let's increase the coefficient of friction here. Way up here. So let's see what happens now. Now it sticks, okay? So that's what the question here is asking about. What is the minimum value for that coefficient of friction so the box does not slip? So how do I do this? Well, you draw a free body diagram of the box, okay? So here's the box. And to do this problem, you really don't even need to know the mass of the box because it ends up canceling out. But let's go ahead and give it a mass. So this thing has a mass here of 20 kg. All right. So now, free body diagram of that box. The force is acting on it. Well, there's its weight. And if the box is a mass of 20 kilograms, its weight is 200 newtons. And if the weight is 200 newtons, that means that the truck bed is pushing up on it with the same force. That's the normal force, which is 200 newtons. And the force accelerating the box is friction between the box and the truck bed. It's friction, folks, acting towards the right. And that's it, okay? And remember, we want to find the minimum value of mu, the coefficient of friction. And so to do that, we know there's this equation for friction that looks like this. Friction is mu times n. So that means that mu is F over n. I know what n is. The question is, how big does that have to be? Well, to figure that out, you write down, you'll never guess this, Newton's second law, which says net force is ma. Okay, and so the net force here is just this friction. So it's equal to the mass of the box, 20 kilograms, times the acceleration of the box, 2 meters per second squared, so that friction force is 20 times 2 is 40, and a kilogram times a meter per second squared is a Newton. So the friction force is 40 newtons. And now you can solve here for mu. So mu is going to be 40 newtons divided by 200 newtons. Okay, so that's going to be 0.02 loop. Bloop, 4 over 20. Let's make sure, I believe it's 0.02. Or 0.2. 0.2. 40 over 200. Watch. Duh, I should know this. Yeah, 0.2. And it's dimensionless. There are no dimensions, okay? Bloop, problem done. You need to work this problem out on your own, starting from scratch, and then you should pause it and see if you can finish it. That's how you learn to do this stuff. And so that is good for now.